coefficient B, hyperbolic differentiation, it is continuous. So, integrate a roots, differentiate f of x, the root of x plus 1 of the first principle. Function is f of x is equal to the root of x plus 1. Now, to differentiate from first principle, we use the formula, the limit of f close to 0, f of x plus h minus f of x, and we divide by h. So now we need to find what f of x plus h is. From there, so whether it's x there, you put x plus h, and then you keep factor 1. Right? So from here we have the limit now. And f of x is 0. So the root of x plus h plus 1 minus x plus 1. Then we will divide by h. So you see, if we substitute where there's h to put it 0, everything becomes undefined. So we don't really have. So then what we do? We write by h. Rationalize, we multiply by the reference layer and also down. X plus x plus 1 planet. Like this. And then we do the expansion. We'll multiply this guy by that guy. And we now have the limit of x plus 0 of x plus x plus 1. And then this guy minus the infinity. We'll get a minus. And that root by that root. We remain with x. Minus 1. So because the minus goes inside, it's supposed to be parents. As this. And then we know the unit expansion then. So if you look at this one, then we divide. We divide by ourselves. Down. Yeah. Then, so we notice that x minus x, that is 0. And 1 minus 1, that's 0. So we have h over h. So h01, h01. So now what is h? We can substitute here. So we have 1 over the root of x plus 0 plus 1 plus the root of x plus 1. Which is just 1 over 2. The root of x plus 1. So for this piece inside is x plus 1. That is x plus 1. So we put them together. So whenever you are taught to use this principle, the idea is h down there. You do whatever you can to eliminate that negative down there. The reason why I want to eliminate it is so that you can substitute 0 and it's h. Because if you substitute 0 with that h down there, everything will be fine. So that's part 1. So we got part 2. Part 2 says part 2 says find dy dx given that y is equal to that kind of a function. One report one. Find dy dx. So given that y is equal to the root of 1 minus x to the power of minus 3x to the power minus 1 over 3. So when you're asked to differentiate and their roots, you write the question. Remember, the root is the power half. And then you now differentiate. So you say, I want to find dy dx.
So for the first one, where you have the same root x plus 1 over the square root of x plus 1 over the root x plus 1. So if they have the same common denominator, you add them. So meaning the answer is 2 the square root x plus 1.
Mm. If there's them, it's like you are not do 1 plus y plus y. You see, it becomes 1 over 2y, not so. If a lot of people are the
Yes.
same and the class, people are different.
Okay.
Okay, so now here we use, for the first part, we use the method called chain rule. Chain rule says, we're given a function y, degree a function g, and to the power n. What you do to differentiate is, you bring down n, maintain the g inside, and subtract the 1 from n, then multiply this whole thing by the derivative of g. Yeah, that's what chain rule says. So in this case, we'll bring down the power. So we'll say we have multiplied by 1 minus x power 4. From half, we subtract the 1, it will become half minus 1. And then we multiply everything by the derivative of the inside. The derivative of 1 is 0. The derivative of minus 4x, minus x4 is minus 4x power 3. Okay. So I've used chain rule for the first piece, and then we move and differentiate the second one. So there we have 3 multiplied by minus 1 over 3, and then x minus 1 over 3 minus 1. Like that, which is equal to. So now this 2 here 1, that's 2 there 2. So we get to have the minus 2x power 3, and then this is 1 minus x4 to the power minus half, And then this 3 here, 1, that 3 here, 1. So look at it from negative. We get a plus, and then we have x minus 4/3. We're now doing the addition of -1/3 minus 1. So you see, 4/1, do the fraction thing, and you arrive at that. And this solution is complete here. You can leave it like that. They're not comfortable, you can push the negative down, but look, even the question and the negative up there. So actually, people ourselves taking things down. You better leave it with the negative power. It's okay because it's correct like that. And in derivatives, you avoid oversimplifying it. You just want the methods to be done. Then that's okay. Yeah. The key thing is to know the formula that I'll have to differentiate this piece. You see? So you first bring down n, work out your n, and then later on differentiate with g. Remove. Go back to the question. So the next question, B1 says, find the equation of the tangent line to the graph f of x to be at the given point. Find the equation of the tangent line to the graph at the given point. So let's then find it. We're detaching methods. That's what is key here. We don't expect to see these questions, but the concept around that we are expecting. The B1 says f of x is equal to x minus 3 over x minus 1 over x squared plus 1 at the point 2 comma 1/5. So we want to differentiate. So differentiate a fraction. Remember, you always want to have the numerator called u. You differentiate it. Multiply by the denominator called b. Subtract by the denominator derivative multiplied by u over this guy. Okay, so what is u? U is the numerator. What is u prime? It's the derivative of the numerator. So the derivative of x is 1. The derivative of minus 1 is 0. What is v? V is x squared plus 1. What is v prime? V prime is 2x. So that's the combination. So u prime is 1 multiplied by v, which is x squared plus 1, minus v prime is 2x multiplied by u, which is x minus 1. Then we'll divide everything by v squared, which is x squared plus 1 to the power, which is equal to x squared plus 1 minus 2x squared plus 2x. Then we divide everything by x squared plus 1 squared. So you see x squared minus 2x squared is equal to minus x squared, and then plus 2x plus 1 over x squared plus 1 squared. So you don't do anything else. You don't expand here, you just write it there. So we go to B part 2. B part 2 says if x squared minus xy plus y squared is equal to 3, find y dx. That's what B said. So if x squared minus xy plus y squared is equal to 3, find the y dx. So where we use implicit differentiation because we cannot make y the subject. So what do? You differentiate x squared and you get 2x. Then you want to differentiate xy. It's a product. So you use product u. Differentiate u v. You differentiate u multiplied by v plus differentiate v multiplied by u. That's a product we have. So you let u have to be x, have to be minus x, I mean. Then you let v have to be y. So we differentiate u, we get minus 1. We differentiate v, we get 1. But look, the question is saying find dy dx, meaning y in the numerator dy means that y is the positive function and x is the product of y. It means that whenever you differentiate y, you need to respect it. That is the whole function. So you multiply its derivative by y here. So we do a combination now. So we have the u prime, that's minus 1. Then we multiply it by the v, which is y, and then do the plus, and the v prime, that is 1 times the y dx. Then we multiply by u, which is minus x, with the y dx. And then plus, we differentiate y squared, we get 2y, but because it's y again, you multiply by the y dx. And then 3, you differentiate 3, now we get 0. What's the constant? So you differentiate everything. So now we solve for dy dx. So from those two, we see dy dx is common. So we have minus x plus 2y. Is that equal to y minus the x? So this y, we take it the other side. This to x, when we take it the other side. And then we'll come back and divide by minus x plus 2y. Divide by minus x plus 2y. So we have 2y. The x is equal to y minus 2x over minus x plus 2y.
Sir, can you just repeat the second part of what you explained?
From the second part, it's right.
For this same question, but the second point, like after the point of the question, but the first point of finding I don't know what you were finding there when you got it to 0. Yes.
So the question itself is saying, can we differentiate this guy? We differentiate y with respect to x. So y is the function and x is the variable. Now we needed to make y the subject, but because there's a square here and there's no square here, it becomes difficult for us to solve for y. Instead of solving for y, we differentiate using implicit method. The implicit method says, oh, you differentiate whatever is x with respect to itself. So we differentiate x squared, we get to x. We differentiate y squared, we get to y. But anytime we're differentiating y, you must multiply by dy dx. Then you differentiate minus xy, it's a product. So we differentiate x with respect to itself and y with respect to itself. But whenever we touch y, we're using implicit. So we differentiate the product, use product which is here. We have u v inside. We differentiate it, I will have u prime v plus v prime v. So from there, I get the first part du, which is negative x. The second part of the product dv, which is y. When I differentiate my u, I get negative 1. I differentiate my v, I get 1. But this one is multiplied by dy dx because I converted to y. And then I want to know this just a simple thing for me. So I have u prime v plus v prime v. And that's why I have used. The question says solve for dy dx. I'm seeing dy dx here. And the dy dx, when I factorize the dy dx, what I remain with from here is minus x, from here is dy. The dy dx is outside. These I take on the other side. Then I divide by this piece because I'm making dy dx or something. That's why I have this.
Okay, sir. Thank you.
Oh, so B1 was saying find the equation of the tangent. We just differentiated. So we go back to B1 and in the derivative, where there is x, we need to substitute 2 because we are given a point 2, 1 on the path. So in the derivative, where there is x, we substitute 2. If we look like that, that would be minus 4. That's 4. That's 1 over 5, which is 1 over 25. So this number we get is called the bracket. It's called the M. And remember, the straight line, the equation of the tangent line is given by y minus y1 equal to m x minus x1. So y minus y1 is 1 over 5, from the point, equal to m is 1 over 25. And then you have x minus x1 is 3. So it's going to be around. No, we could not just cancel because if there was x squared plus 1 And then there is minus. Whenever there is minus, you don't just control out anything that looks similar. You don't do that. You don't multiply. So you mean here? Again, here is not possible. Because this is x minus 1. You expand, you get x squared minus x. And down you have x squared plus 1. This x squared plus 1 cannot be cancelled by this because of that minus. And this you factorize after.
Okay.
Okay, let's go to question 4 now. In part 1 says, evaluate the limit evaluate the limit as x goes to -1. So this is the limit. So this is the limit. In part 1, it's the limit of x approaches -1. 2x equal to minus x plus 1 divided by the cube root of x3 minus 7. So whenever you're asked to solve a limit, the first thing you do is you substitute whatever is x, you put the number given. Squared by x minus 1 plus 1 over the cube root of minus 1 plus 3 minus 7. That is 2 plus 2 there, because this will be plus 1, and then plus 1 over the cube root of minus 1 minus 7. So this will be 4 over the cube root of minus 8. The cube root of minus 8 is minus 2. So we get minus 2. So where we can substitute, we just substitute in the value. It doesn't mean that every time we can factorize things and like no. And then part 2 says the limit as x goes to infinity for 5x minus 2 over 4 minus 2x. Whenever the limit is going to infinity, the target is always to factorize the denominator x. So this x within the denominator is factored out, and we have 4 over x because we are dividing it into minus a 2. When you factor out, you divide everything remaining there. This same x coming from down, you factor it out from the numerator, you have a 5 minus 3 over x. And so now this x and this x cancels. Then you remain with the limit of x goes to infinity of 5 is just 5. And the limit of x goes to infinity of 2 over x Remember, it's 0 over 0 minus 3, which is equal to 5 over negative 3. Like that. Okay. And so we do the other piece, part 3. So part 3, you have the limit of x plus 2 and the square root of x squared minus 4 over 1 x squared plus 5x minus 13. So if we substitute it directly here, you have a 4, and then we have a 0 over 0 down here. So what you do is you don't substitute direct, instead you factorize the numerator to the x minus 2 to the x plus 2 because it depends on this side. You factorize the denominator. So two numbers you can multiply to get 14. And the numbers are 7 and 2. One of them should be negative. So you have minus 2x. 7x minus 14. Then you factorize like that. Okay. So when this video cuts, then we rejoin again.